Welcome to Mark TV episode number 2. Are you ready to learn more about MongoDB Atlas beyond the UI? Join us for a recap of an interesting session tailored for DevOps enthusiasts from America's West virtual MongoDB Meetup. In this session, Darshana and Zubair talked about alternative methods of using MongoDB Atlas beyond the UI. They presented powerful approaches such as MongoDB Atlas Terraform Provider, CloudFormation Resources, CDK, Quick Start Partner Solution Deployments, and the Atlas Kubernetes Operator. They'll also give a live demo on creating your first MongoDB Atlas cluster using Atlas Terraform Provider. Hope you find this session interesting, and please feel free to comment in the comment section below if you have any doubts or questions for the presenters. I will give it to Darshan and Zuhair to kick off their session and talk through us all the DevOps integrations.
Perfect. Okay. Can you guys see my screen?
Yep.
Yes.
Perfect.
Yes.
All right. All right. Thank you, Veronica. And this was like, I'm super excited to be talking to this group because clearly you guys are very passionate about MongoDB and Grafana. So in this session, we'll be talking about how you can get started with MongoDB Atlas programmatically. I'm Darshana, and I am part of the product marketing team here at MongoDB. I focus on everything related to DevOps. And joining me today is Zuhair. Zuhair, want to say hi?
Hi, super excited to meet you guys. Zubair, Senior Product Manager at MongoDB.
Cool. So we are super excited to be talking with you about this topic. So today in this call, we'll be introducing MongoDB Atlas. I'm sure a lot of you are already familiar with it. So let's go through that. We'll then talk about the different ways with which you can get started with Atlas programmatically. We'll have a little bit of more focus in this session on infrastructure as code integrations that we offer with AWS CloudFormation as well as HashiCorp Terraform. And then Zuhair will be walking us through a demo where you will learn how to create your Atlas cluster and the other resources using Terraform. So let's get started. So MongoDB Atlas, I'm sure a lot of you are already aware, but MongoDB Atlas is our fully managed database that we offer. We call it the developer data platform for reasons which I'll be talking about now. The first thing that you need to know is that MongoDB Atlas is based on the document model. So as compared to your relational databases where you store your data in rows and columns, a document model basically focuses on storing this information in documents. Information which is accessed together, is stored together. It's much more intuitive for developers to work with a document-based model. Also, you don't need to worry about it. It has a very flexible schema, so you can keep adding fields very easily. And also, you don't need to worry about expensive joins. You don't need to worry about mapping to the ORM layer. All of this makes it super simple to work with MongoDB Atlas. Not only this, we've seen a lot of customers where if they're working with relational databases and if they want to support some new use cases, they have to add on top of their relational databases some very point solutions or point databases which could be focused on transactional, or add a database for transactional workloads or a dedicated search engine or a stream processor, which makes it very, very complex, and it gives developers a very disjointed experience when interacting with all of this, architecture. So imagine if you get all of this in a single platform, and that is the power that MongoDB Atlas or our developer data platform gives you. We support a lot of use cases, be it your transaction processing, where you're looking at potentially inventory data and doing some analysis on that, time series, full text search, analytics. These are super important use cases that MongoDB supports or Atlas supports. And we are also excited to bring two more announcements. In June at our .local, we announced this. The first one is stream processing, where you can also work with streaming data. So basically, use cases could be something like looking at your financial data to understand if there are any fraudulent transactions, or looking at any e-commerce website data and changing pricing on the fly, depending on user behavior. So those kind of event-driven architectural applications are also supported by Atlas. And of course, we've all heard about AI and Gen AI. So MongoDB Atlas is the data platform for you to, if you're interested in developing applications like those, because we introduce vector search, which is like the underlying layer which supports such applications, right? So if you're using, or if you have queries such as recommend movies which are similar to this, or recommend songs which make me feel XYZ, right? All of these can be supported through vector search. At the highest level, what vector search is that instead of querying the data itself, we are querying it based on the information around the data, which is vectorized, and it's in the form of a number, right? And then you can easily compare those based on algorithms, and the use cases that I mentioned could be easily worked on with vector search. Not only this, MongoDB it gives you all of these use cases. That's awesome, but it's truly multi-cloud in nature. So today we are present in more than 110 regions across the three major cloud providers, Amazon, Google, and Azure. And we are highly resilient, performant with all of the security features that you can expect, so everything to do with authorization, authentication, the best in class encryption, compliance with a lot of these industry policies such as HIPAA, PCI, and also, we are FedRAMP moderate authorized. So all of this goodness you get in our developer data platform, which is MongoDB Atlas. So now that we know at the highest level what Atlas is, what are the different ways that you can get started with Atlas? Obviously, the first thing that comes to mind, or many times our customers first start with the UI or our user interface. We have a super awesome, rich UI that we for Atlas. But as you start scaling, and when you want to start adding some programmatic approaches, when you want to start automating, when you want to start creating clusters at scale, that's where these programmatic approaches, when working with Atlas, come into play. So the first way to get started programmatically with Atlas is the Atlas Admin API. Now, this is a RESTful API, and pretty much what you can do in the UI from an administrative standpoint, right? So creating your database user, your access list, backups, anything, or all the Atlas resources that you can create, or all the administrative things that you can do in the UI, you can pretty much do with the Atlas Admin API. You can't really work with data. For that, you might want to use your data API, or you might be able to use tools such as Shell or Compass. But all in all, with the Atlas Admin API, whenever you're creating resources, you have to write curl scripts or commands. And this can be a little manual. So for that, we introduced the Atlas Go HTTP client, which kind of abstracts away the complexity in working with HTTP. And in June, we also announced Go SDK, which is a much more simpler form for Go developers to get started with the Atlas Admin API with fewer lines of code, because it has a lot of inbuilt, functions and structs, which kind of, again, remove the complexity of working with HTTP. So that's the Atlas Admin API. And all the tools that you see below, right? The Atlas Kubernetes Operator, our infrastructure as code integrations, and the CLI are built on top of the Atlas Admin API. So each of these tools use the Atlas Admin API to create the Atlas resources that you define. Let's go through these tools in short. The Kubernetes Operator, if you're already having your Kubernetes, your applications running in Kubernetes, you're heavily ingrained in Kubernetes practices, you really can, and you want to include Atlas in your stack. The best way for you to get started is through our Atlas Kubernetes Operator, because it allows you to configure and deploy Atlas resources using your existing Kubernetes tooling and just managing Atlas from within Kubernetes in a very Kubernetes native way, right? So it's a very easy way for you to get started with Atlas. And of course, many of you are using Terraform or CloudFormation as your infrastructure as code tool of choice. And as you want to add Atlas to that stack, we do have the integrations which will make it super easy for you to get started. And a lot of our customers also start their journey with the CLI or our command line interface with simple commands. Everyone likes it because there are a lot of these simple commands which help you to quickly spin up clusters. For example, there's a Atlas setup, which will help you create the first free tier or the first free cluster, load up some data, and connect to Shell. So these are some of the ways with which you can get started. Pretty much what your use cases you can define, and it could be your entry point to get started with Atlas. And the best part is that all of these tools are free to use. Of course, you'll be paying for the resources that you create using these tools, but very simple and free to use. So with that, in today's session, we really want to focus on the infrastructure as code integrations. And just taking a step back, infrastructure as code at the highest level is, as the name suggests, similar to how you create your application code and check it into version control systems like GitHub or Bitbucket, right? In a similar way, you can define your infrastructure configurations as code and check it into the same systems, which means that they'll be going through the same tests. They can be easily integrated into your CI/CD pipelines. You can easily understand if there's any configuration drift. There's an easy log of all the things or changes that are made. And also, it's very easy to replicate environments, right? So if you want a similar configuration or deployment created for your dev, test, prod, right, you can easily do it by replicating these environments using infrastructure as code. So that's all the goodness that infrastructure as code offers. And two of the most commonly used tools today are HashiCorp Terraform and AWS CloudFormation. And the good news is that we have integrations with both of those. So let's take a look at each of these. The first one is our AWS CloudFormation, or how you can get started. If you're an AWS CloudFormation user, how can you deploy MongoDB Atlas and the Atlas resources? The first way to get started is directly by deploying these resources from the CloudFormation registry, and you can execute it using the AWS CLI or the management console. Here, you'll have to individually deploy the resources per your use case. The second way, a much easier way, is the partner solutions, which was also previously called as quick starts. And as the name suggests, it kind of makes it easy because a lot of resources are grouped together for specific use cases. And the third one is the Cloud Development Kit, which adds a layer of abstraction, and it's gaining a lot of traction because pretty much if you're a developer who's passionate about Java or Python, you can write your infrastructure as code configuration in a language of your choice without worrying to learn about YAML or JSON. So a much easier way to get started. So let's look at each of these a little bit in detail. So the CloudFormation resources, as I had mentioned, all the things that you could do with the Atlas Admin API from an administrative standpoint, creating your database user, your password, your access controls, your advanced cluster, all of that is possible through the CloudFormation resources, which you can easily download from your CloudFormation registry. And the configurations are defined in YAML or JSON format, right? AWS, when you're using CloudFormation, the only one thing to remember or to understand is that you can provision your Atlas resources on AWS cloud only. Another way to get started with it, the partner solutions, is much simpler, as I mentioned, because they group together a couple of resources for specific use cases. So as of today, we have 3 partner solutions, or formerly known as quick starts. If you want to, the first one, right, the Atlas partner solution, if you want to just create an Atlas project, you want to deploy a basic M10 cluster in a single region with or without VPC peering, you can do all of that with a single click through the Atlas partner solution. And of course, you can customize it based on your requirements, but it gives you a quick start to begin with. If you're interested in creating a Java-based serverless application, right, you want to include MongoDB Atlas with Fargate solutions, you can use the second quick start or partner solution, which allows you to deploy all of these resources very quickly. And the third quick start we have is with the Amazon SageMaker. So if you're looking at any kind of AI ML applications, you can again deploy all of the components very, very easily with this quick start or partner solution. And the third way, again, to get started with CloudFormation, a way which is gaining a lot of traction, it was first started by AWS in 2019, and it is gaining a lot of traction since then, is how you can provision your Atlas resources through CloudFormation using these CDK applications. So all in all, if you are already a Java user, if you're a Python user, you don't need to worry about JSON or YAML. You can write these AWS CDK applications, and under the hood, when the application runs, it pretty much uses CloudFormation to deploy all of your Atlas resources that you've defined. So again, a very easy way for developers to get started in a language of their choice. With that, I would love to change gears to Terraform. And again, when you're looking at Terraform and how do you deploy your Atlas resources through Terraform, these are the 2 big ways that you can get started. The first one is through the Terraform Provider, which you can easily find on the Terraform registry, and you can execute via the Terraform terminal. And another way is similar to the AWS CloudFormation CDK that we looked at. We also have a CDK TF, which is CDK for Terraform, which again allows you to deploy Atlas resources through Terraform using a language of your choice. Now, the Atlas provider, very similar to the CloudFormation resources that we looked at. It allows you to provision and manage all of your Atlas configurations as code. The big difference is that Terraform is cloud agnostic, so you can deploy these resources across the 3 major cloud providers. So truly, if you want to start your multi-cloud journey, that's the way to begin. Here, the configurations are defined in HCL, or the HashiCorp configuration language. And here is a list of all the resources that you can configure. I've added a link to the list, so you can take a look at the full list. This is just a snapshot of it. Now, one thing I want to highlight is the last I checked, the Terraform provider has 15 million downloads through the Terraform registry, which I think is amazing and truly shows how much traction we are gaining through the developer community focused on using Terraform to deploy Atlas. And it's actually the highest in that database category in the Terraform registry. So super excited to share that number. And then the second way for you to get started with Terraform is through the CDK. And similar to the CDK for CloudFormation, CDK TF allows you to deploy your Atlas resources across any of the 3 clouds, right? And under the hood, when these CDK TF applications are run, it uses Terraform to deploy your Atlas resources very, very easily. Again, you can do this using a language of your choice without worrying about learning HCL, right? So those were the different ways in which you can get started. And I would love to hand it over to Zubair for a quick demo. But before that, I want to make sure if there are any questions that I can answer. Okay, I don't see anything in the chat. So Zubair, I'll pass it on to you and maybe we can leave some time in the end.
Sure.
Stop sharing my screen.
Yeah, no, that was wonderful. I really appreciate the overview. Maybe I actually really like doing this as well. Let me share my screen. And Darshana talked about how we just crossed over the 15 million downloads over our time on the Terraform provider, but I just wanted to bring it up on the Terraform registry. Just for the folks who aren't really aware, Terraform is the 800-pound gorilla in the room. It is the most popular IAC or infrastructure code tool by far. And what's exciting is that within the database category, we're number 1, which is really good, and it's a really big thank you to everything that the folks on this call and all the MongoDB champions and the user groups out there. It really begins to show like the benefit of not just the document model, but that whole broad understanding of leveraging the idea of a developer data platform. So big kudos and thank you. As we're running through the demo, it's going to take a few minutes to actually spin up the clusters, and I'll plan to go through the documentation and I'll walk through our website a little bit more. But with all that out of the way, let me just kick it off. Again, my name is Zubair Ahmed. I'm a senior product manager at MongoDB. I help support some of our infrastructure as code tools like Terraform, like CDK, like CloudFormation. And today we are going to get our hands dirty and we are going to deploy your very first M0 or free tier MongoDB cluster. In order to get set up, you will need, feel free to follow along, you will need a MongoDB Atlas account. It's very easy to set up. No credit card is required. It's just cloud.mongodb.com. You set up your username, your password, you link it to an email, you authorize an email, and you're off to the races. Once you've done that, your screen should look very similar to what you have, which you should see on mine on the right hand side. And the very first thing that we're going to do is we're going to set up something called programmatic API keys or PACs. And this is effectively the keys that we need to tell Terraform which account to deploy into, where to create and spin up all these resources. So what I like to do is I like to go into Access Manager on the left-hand side, and then API keys tab over there, and we're going to click this box, Create API Key. So let's call this test 5. And you want to make sure that you give yourself sufficient permissions when you're creating programmatic API keys. You can see a quick description of what each of the roles mean. We're going to be focusing on organizational owner role, which effectively allows you to manage the account, and you basically have all access to your Atlas resources. And these are your public and private keys. These are secrets. So you want to make sure to keep that in mind. What I like to do is as soon as they're only showed once. So what I like to do is like to copy them and put them right into my Terraform script, because these are the keys that we'll be using. And no worries, these are just for demo purposes, so they will be wiped out after this demo. There are integrations that we have with a few other HashiCorp offerings, including HashiCorp Vault. So if you are an organization and you're growing and you are worried about secrets management, these do tend to be a lot of undifferentiated heavy lifting. Well, how do you think about rotating these secrets? How do you think about managing them at scale? How do you make sure that the right users in your organizations have the right level of permissions? Well, that's all what HashiCorp Vault is all about. So happy to talk about that as well if other folks are interested. So I copied and pasted the public and private keys there. The other thing that we need to do while we're on the screen is we need to add our API access list. This is going to be the IP address where we're going to be deploying the MongoDB Atlas clusters. You normally would be entering an IP address, but if you're not sure of your current IP address, we have this helpful button, use current IP address. So this is mine, I'm going to save it. So hopefully that's great, that makes sense. Alternatively, if you don't want to use your IP address or for whatever reason you want to make it all access, we have a helpful blog post out here, which I will be sharing the link out at the end of this demo that walks you through all the different scenarios. But what you can do is you can make it open to all access with 0.0.0/1 and 128.0.0/1. It's not recommended for prod, but I do find it helpful for dev and testing purposes if you do need to make your database access open to the internet, to the wide internet. Okay, so that's good. So congratulations, we just created our first programmatic API keys. Next, what we're going to do is we're going to switch over to the Terraform side on the left-hand side. Now, I have copied some dummy code in here. Everything is available on our repo. Again, links will be provided at the end of this demo, but it's just MongoDB/Terraform-Provider/MongoDB Atlas. You can also just Google us and you'll come to our repo, and it's we're leveraging one of the examples in the examples folder, and then just the starter example. So everything that we're doing here is also on the repo, so no need to worry or to copy paste. It's all made available for you. First things first, if you're brand new to Terraform, the one thing that you want to be aware of is that this is an empty directory, and I have exactly one file in here. It's just called main.tf. At the very top of it, you'll see that there's a block here for required providers. The real power of Terraform is that we can leverage multiple providers together. So for example, if you were going to use MongoDB Atlas and AWS or Grafana or a whole host, Prometheus, a whole host of other providers out there, you have that kind of flexibility to do so with Terraform. For this demo, we're only going to be using just one, which is MongoDB Atlas. Pro tip, if you don't specify the version for MongoDB, it will automatically, you'll see when you hit the Terraform apply, it will automatically pull the latest version. If you ever are unsure of what is the latest version of our Terraform provider, it's always available on our repo. Once you get to our main folder, you can see that our release is 1.11.0, which was released last week. And also when the cluster is loading, I'm happy to talk about our roadmap and some new exciting features we have coming out on the Terraform side. So hopefully that block makes sense. We're basically just telling Terraform that, hey, listen, we're just using one provider, which is MongoDB Atlas. Second, we already pasted our public and private keys here. There's a few different ways to do this. I am hard coding our keys in here, which is not good security practices. A better way to do this is to either use environment variables or to use an integration like AWS Secrets Manager or HashiCorp Vault. But this is fine for I think, again, for demo purposes. And then we're going to be creating 4 new resources. This is important. These are basically the 4 resources you'll need for any MongoDB Atlas deployment that you're likely going to be managing. The first is called a MongoDB Atlas project, which is the overall environment where all your resources will live. Your project IP access list. There's no point of having a database cluster if you can't access it. So this specifically specifies the IP addresses that are available for that database cluster. Note, this is different than the IP access list that we made for our programmatic API keys. right? The way, and I think Darshana explained it well, is that there's a separation between control plane and data plane. Everything that we're doing on our end is with the Terraform deployment and with all the different programmatic API tools is the control plane. So this is the management and administration layer of all the different resources. What this IP addresses here is specifically the users that want to access your database cluster. So who are the folks, who are the IP addresses that will ultimately be able to have access to your cluster? And that's more on the data plane side. So that's the second resource. The third resource will be making a database user. Again, there's no point of creating a cluster if you don't have credentials to log in and access to it. So this is the username and password and the roles that you will need to access that cluster. And then last but not least, this is the actual cluster itself. It's called MongoDB Atlas _advanced cluster. And we'll be using an M0 cluster for the deployment. So those are the four. Again, just at a high level, the only few things all the code is available online, and everything is in HCL, HashiCorp configuration language. The only just few things I want to highlight before we actually deploy this is that for the actual project resource, there's two required fields: the name and the org ID. So you'll see that we're calling this my first project for the project. The org ID, I'm going to show you how to pull that. You just click on, if you're in the Atlas UI on the right hand side of my screen, you click on the gear icon, and you see the very first thing under organizational settings is organizational ID. So you want to copy that org ID and you want to paste it in here, which is already there, which is great. And then for IP access list, the same method that I showed you how to get your IP access list, your IP address with your keys, you can leverage over here as well. I just pasted my existing IP address. The cool thing about Terraform is that instead of having to rewrite the same variable name again and again and again, you'll see what I'm doing a few times for project ID. I'm basically leveraging MongoDB Atlas project dot test project dot ID. So instead of having to rewrite the ID that I'm getting for the project, I'm creating the project dynamically, and then I'm able to get that ID and leveraging it into another resource, which is cool. And I actually really like that aspect a lot about Terraform. Database user, username, password, roles are self-explanatory. Again, everything's available in the documentation. On the cluster resource, just a few things I want to highlight. We are doing this deployment on AWS. And we're deploying a M0 cluster on US East 1. Again, M0 or the free tier cluster is great. It is always free. You don't know, again, no credit card is required. And it's good for allowing you to actually see whether your deployment would be successful or not. It's also really good if you're ever just curious about just getting started. You don't want to spend any money. This is a good resource for that. And that's it. Those are the four main summary resources. Let's jump into the deployment. So I'm going to open a new terminal window, and let's get rid of all this stuff. My terminal's a little bit easier to see. This guy. Cool. Okay. The first command that we're going to walk through is called Terraform init. And this is basically going to be initializing the actual software for Terraform. There's a bunch of documentation outlined. It's beyond the scope of this demo is the actual installation of Terraform. But if you just Google, how to install Terraform, this is an Ubuntu Linux instance, so you can get all the instructions. It's fairly easy to get Linux installed on your machine and get ready to go. Once you have your Terraform initialized, everything looks great. Terraform has been successfully initialized. Great. I'm going to clear my screen, and then I'm going to do a Terraform plan, which is my favorite command within Terraform. Terraform plan actually doesn't deploy anything. It's a check. So it allows you to actually see all the different variables and all the different resources that have been created. So I see cluster, I see database user, I see project IP access list, and I see project, which is great. So 4 resources to add, 0 to change, 0 to destroy. So this is really helpful in cases where you're thinking about deleting something or adding something. You can actually verify what you want to do and what Terraform is about to do is aligned. And then we're going to do Terraform apply. Terraform Apply is the actual deployment. It's going to be basically taking our config file that we've written and converting that into API calls. And then as Darshana showed in her flowchart, those API calls are going to be converted or are going to be translated and then hit our Go client, HTTP Go client, and those are then going to hit their Atlas admin API. So there's a few levels of abstraction. Are you sure you want to deploy? Are you sure you want to perform these actions? I'm going to hit yes. And let's look at this in real time to see what actually is happening. I'm going to go back into my Atlas UI or user interface. And I'm going to hit refresh, and looks like a new project is made, my first project. So let's click on here to see what's going on. Again, this was something that we created together in Terraform. And you'll see a database deployment is being created. Same thing on the left-hand side of the screen. You can see the time ticking, 10 seconds elapsed, 20 seconds elapsed. It usually takes about 2 to 3 minutes to create a free tier cluster. So while that's spinning up, let's click on the left-hand side and click on database access. Yep, I see user 1. The name, just to double check that we called our database user was user 1. Perfect. It looks like that was created successfully. And let's look at our network access tab. This will actually be our IP address that we included, the 50.89.69.57, which is the same that we have over here on our Terraform script. So it looks like our database user was created, our project was created, and our IP access entry was created, which is awesome. That's 3 out of 4. I'm going to go back, and it looks like our database is my first cluster is being created as well. Perfect. Looks like about 1 minute has elapsed, and we'll see this guy being set up to use momentarily as it's being spun up. While this is loading, while we confirm, I'm going to go back and just show you quickly our documentation. I know I went through it relatively quickly, but if you did want to look, for example, into our, let's say, advanced cluster resource, we have included examples on every single type of parameter that is required, that is optional. You'll see our tenant cluster, which is a shared tier cluster. If you're ever curious how to deploy a multi-cloud cluster on MongoDB Atlas, which is actually really interesting, you can have one node which is in AWS, one node which is in GCP, and one node which is in Azure, all laid out for you in a clean Terraform script, which is kind of cool. Yeah, so when in doubt, I would just recommend, use the documentation, which is awesome. Let's look really briefly into our project resource, if you're curious. And you can see, again, examples of the different parameters to use, and you can see how both the name, the org ID were required, which is what we did as well. So hopefully that makes sense, at least at a high level introduction into our docs. Let's see, this is still loading. So while this is going, as a small treat, let me just give you a quick heads up on our roadmap. I'm going to go into, when in doubt, you can always go to our changelog. This is actually one of the more visited pages on our repo, and this actually lays out all the different key updates that we've been laying out for each of the different versions. And just this as a quick heads up, we have support for shared cluster backups. So instead of using like a full tier cluster, if you wanted to use like an N2 or M5 cluster, you can use that. Or if you're interested in using Azure Service Principals, which are like a cloud provider access from AWS, if you're familiar, on Azure, we now support that with our Terraform provider. A few big updates that came out with 1.10 is now that we're allowing programmatically creating organizations. We're allowing folks to use endpoints with federated database instances. We have new support for programmatic API keys. We have support for cluster outage simulation. We upgraded to on the back end to latest Go 1.20. So we try to be pretty quick with the Atlas team, which is always increasingly challenging. As new updates come on in Atlas, we try to be within a few weeks, within a few months, try to get those features out and exposed in Terraform. So I'm going back and I'm looking at my Terraform script, and it looks like our apply was successful. It looks like 4 resources were added, which is awesome. I'm just going to hit refresh on my screen, and we can take a look at our free tier cluster. And this should be everything that you need to get started. I'm just going to click on connect, and we can even go to Compass, and we can get our connection string. So just like that, within 3 minutes exactly, we basically went from nothing, an empty Terraform file, into a deployed M0 cluster, and now you have your connection string. So if you were going to open, there's a few different ways you can actually cluster, but if you're going to open MongoDB Compass, which is one of my favorite methods, this is a GUI. You can paste that in there, and just keep in mind the password that you used for this deployment. And we use password1 capital P. So let's put this guy in here. Password1 capital P, and connect. And we're connected. So cool. So like and just to quickly summarize, in this demo, we deployed our very first M0 cluster. We created four of our main resources, which is our database user, IP access list, project, and cluster. We then got our connection string, and then we connected to that database with our GUI, MongoDB Compass. So hopefully that helps at a high level. That is it from my end. I am going to pause in case there are any questions, comments.
Yeah, there were a few questions here. Like one was around the roadmap. So you can see it in the chat. Does the roadmap for the Terraform provider include adjusting collection indices? I think it does. I mean, I must have missed that, but yeah.
Yeah. So this is something that we get a lot. We try to separate our control plane and our data plane. So we are hopefully looking to make it a little bit easier for folks to access databases and collections via Terraform. It is not supported yet. We're hoping that sometime within the next few quarters we can get there, but it's not available just yet. That's a good question. Good question.
There's more in the chat. Yeah. So, sorry, Darshana, go ahead.
Yeah. The other one was around what steps should be taken care of during the LDAP configuration via Terraform in Atlas.
Great question. Yeah, so we have a whole demo on, actually, if I can just share my screen one more time. If we go back to our repo, you will see a whole host of examples in here, including LDAP. So you should have lots of the resources that you need. Whether you're looking at VPC peering, without VPC peering, you're looking at LDAP, looking at federated database instances. So I would suggest go to our examples folder, and you should see, hopefully starter examples, everything they need to get started. If there are examples that you'd like to see there, let us know. We're always looking to make it a little bit easier for our users. But hopefully that answers your question. Okay, I see one last one. What is the strategy for prior Atlas org/project instances that have existed in the past several years with existing prod dev environments that have been grown organically to generate the Terraform templates in its sync with the current organic environment, so we can start managing from Terraform onwards? Yeah, so this is an interesting one, Jim. Thanks for the question. So there's a few different ways I think you can tackle it. One is through a tool called Terraform Import. So if you've created existing Atlas resources in the past, you can import them into your Terraform config file. Again, this is purely managing the Terraform state. You don't need to create or destroy anything on the Terraform side. The other thing that, and just to be aware, just in connection with our HashiCorp colleagues, there are going to be updates if you are leveraging the paid versions of Terraform, so particularly Terraform Cloud or Terraform Enterprise. There are auto imports available. So if you are interested in leveraging that, feel free to contact your HashiCorp rep who can help get you started a little bit faster. But great question. Cool. I think this is everything, unless I'm missing anything.
Yeah, there was a question on sharding. How does it work with sharding? So.
I'm sorry. Well, how does what work with sharding? How does Terraform work with sharding?
Yes. Mm-hmm. whether you can, I guess.
Yeah, you can create a few different types of clusters. If you are looking to create a global cluster, you could make it sharded or unsharded. What I would recommend is if you go back into our repo, there are specific examples on sharded clusters. The other thing that you can do is if you run into any issues at all, feel free to create an issue on our GitHub repo. Either myself or someone else on my team we're regularly monitored. So if you ever run into any issues, Amit, happy to help. Cool. I think if that's everything, I can pass it back to Harshit.
Yeah, thanks, Zubair. Thanks, Darshana. Thanks for taking us through all the details and answering all the questions as well. If you have more questions, please feel free to let us know in the chat.